There's an unbreakable limit in our universe, a rule so rigid, so absolute, that if it were broken, the very fabric of reality would tear beyond repair. I'm talking about the speed of light, 300,000 kilometers per second. Nothing can travel faster. Nothing can send a signal, information, or a force beyond this threshold. This is the bedrock of all our physics, of our entire understanding of space and time. If anything crossed this cosmic speed limit, the consequences would be devastating. Cause would come before effect. You could see a glass shatter on the floor before it even fell off the table. And yet, at this exact moment, in underground labs isolated from the rest of the world, physicists are observing a phenomenon, quantum entanglement, that shows instantaneous correlations between particles, whether they're a meter apart or spanning the entire diameter of the galaxy. Albert Einstein called it spooky action at a distance. Einstein was deeply disturbed by this instantaneous action and believed that, if it were real, quantum mechanics had to be incomplete or its interpretation was wrong. But Einstein was wrong. What you're about to see isn't science fiction. It is the most mind-bending, rigorously tested phenomenon in modern science. It's called quantum entanglement, and to understand it, we need to descend into the abyss of the infinitely small. Imagine standing inside a special crystal, cooled to a temperature near absolute zero. In here, thermal chaos stops. There is only silence. At the center of this space, we have a single atom, excited by a laser beam. This atom has too much energy and needs to release it. It does so in a fraction of a second, firing out two particles of light, two photons. But these aren't just any two photons, because they were born from the exact same event, from the exact same quantum reaction. They share a profound bond. The laws of conservation of energy and momentum dictate that their properties must balance out perfectly. If one spins one way, the other must spin the opposite way. Their total sum must be zero. They were born as a single mathematical entity divided into two physical bodies. They have become entangled particles, intertwined. From this moment on, their destinies are fused together in a way our macroscopic minds struggle to accept. But to understand how deep this bond really is, we first have to separate them. Let's take these two newborn photons. We funnel them into two separate fiber optic cables. Photon A is sent north, traveling at 300,000 kilometers per second. Photon B is sent south at the exact same speed. They are moving apart at twice the speed of light. In just 1 second, there's already a distance of 600,000 kilometers between them, more than the distance between the Earth and the Moon. Physically, they are completely isolated. There is no visible wire connecting them, no magnetic field acting as a bridge. There is no known force in the universe capable of traveling between them fast enough to allow communication. According to classical physics, Photon A has no way of knowing what Photon B is doing. They've become independent entities, lost in the vastness of space, or at least that's what common sense tells us. But the quantum realm doesn't care about our common sense, because there's a crucial detail I haven't told you yet about these particles as they travel, a detail that changes everything. While they travel, these photons don't have a defined state. They aren't red or blue. They aren't spinning up or down. In quantum physics, until a particle is observed, it doesn't possess fixed properties. It exists in a superposition of states. It's like a coin spinning in midair. It's neither heads nor tails. It's a blurry whirlwind of both possibilities at once. Both of our photons, traveling at insane speeds in opposite directions, are spinning coins. They are clouds of probability. The math tells us they hold all possible answers at the same time. This doesn't simply mean that we don't know their state. It means the universe itself hasn't decided yet. The reality of those particles is literally suspended, waiting for an event to force it into a concrete shape. And that event is measurement, the act of looking. But what happens when we decide to stop the coin and check the result? Brace yourself, because this is where reality breaks. We place a detector in the path of Photon A, a wall of crystal and silicon. The photon crashes into the detector. In that exact infinitesimal instant, the superposition collapses. The coin lands on the table. The universe is forced to make a choice. The detector clicks and tells us Photon A has a vertical or horizontal polarization. The particle has finally taken on a defined reality. But here's the mind-blowing part. At the exact absolute split second that photon A becomes up, photon B, which is dozens or hundreds of kilometers away in these experimental demonstrations, stops being a cloud of probability and instantaneously becomes down. Not a millisecond later, not a billionth of a second later, instantaneously. The time it takes for this coordination is zero, absolute zero. If we measured the two photons at the exact same cosmic moment, we would always find in 100% of cases that their results are perfectly opposite and correlated. How did photon B know what happened to photon A? How did the information cross empty space at an infinite speed? Albert Einstein couldn't accept it. To him, this instantaneous action was an insult to logic. In 1935, along with two colleagues, he wrote a paper to debunk this madness. Their argument was brilliant and comforting. Einstein said, "Imagine having a pair of gloves, a right one and a left one. You put them in two identical boxes and shuffle them. You send one box to New York and one to Tokyo. Whoever opens the box in New York and finds the right glove instantly knows that the left glove is in Tokyo. There's no magic. There's no faster-than-light communication. The gloves were right and left from the very beginning, ever since they were put in the boxes. We simply didn't know it." According to Einstein, entangled particles worked exactly like this. They had hidden variables, secret instructions coded inside them from birth. The universe had already decided their fate. The superposition was just an illusion caused by our ignorance. It seemed like a perfect explanation, rational, comforting, but there was a problem that would keep the most brilliant minds of the 20th century awake at night. For 30 years, Einstein's glove theory seemed unassailable. No one knew how to prove otherwise. Until in 1964, a Northern Irish physicist named John Bell devised a brilliant mathematical trap. Bell realized we shouldn't just measure the particles in one direction, like up or down. We had to interrogate them from different angles randomly and at the very last second. Imagine interrogating two suspects in separate rooms. If their stories always match perfectly, they might have coordinated beforehand. But if you start asking weird, unpredictable questions from unexpected angles, and they still answer in perfectly correlated ways, then they aren't following a pre-written script. They are communicating telepathically during the interrogation. Bell wrote an equation, known today as Bell's theorem. This equation set a strict upper limit. If the particles had a secret plan from the start, like Einstein's gloves, their correlation could never exceed a certain mathematical number. If they exceeded it, it meant the particles were exhibiting instantaneous correlations, a phenomenon known as non-locality, but not that they were communicating information in real time. The stage was set for the most important experiment in the history of physics. In the following years, right up to the present day, scientists built increasingly complex machines to test Bell's theorem. They shot entangled photons through fiber optics under entire cities. They fired them up to orbiting satellites. They even used the light from quasars billions of light years away to decide, with absolute randomness, which question to ask the particles. They wanted to be certain beyond any reasonable doubt that there was no trick, no hidden local influence. And every single time, in every single experiment, the particles violated Bell's limit. They answered too perfectly. They broke the mathematical threshold. The verdict is unequivocal. Einstein was wrong. There are no hidden variables. There is no secret pre-written plan. Before measurement, the state of the particles literally does not exist. And when one is measured, the other assumes its state instantaneously. Our universe is not locally real. Things don't have defined properties until they interact, and objects separated by intergalactic distances can be intimately bound together. It's a proven scientific fact. But how is this possible? To make sense of this paradox, we have to stop thinking of space as an empty container where things move around. Space is not the passive stage of the universe. In quantum physics, the physical distance between two entangled objects might just be an illusion. Imagine a two-dimensional sheet of paper. You draw two dots on opposite ends. To the beings living on the paper, those dots are incredibly far apart. But if you, from the outside, fold the paper in half, those two dots touch. They are the exact same thing in the exact same place. Some theoretical physicists suggest that entanglement works in a similar way. The two particles might be connected through extra dimensions or through microscopic tunnels in spacetime, tiny wormholes that escape our perception. When you measure one particle, you aren't sending a signal through space to the other. You are touching the exact same mathematical entity from two different access points. It's like pulling the two ends of a rope passing under a rug. They look separate, but beneath the fabric of reality, they are one and the same. And this brings us to an even more unsettling question. Until recently, we thought entanglement was a fragile phenomenon, limited exclusively to photons and single atoms isolated in a vacuum. We thought that as soon as the system got a bit bigger, a bit warmer, interaction with the outside environment would destroy the bond. This process is called decoherence. It's the reason we don't see macroscopic objects behaving quantum mechanically in everyday life. But science is pushing this boundary further and further. In recent years, researchers managed to entangle 2-millimeter-sized vibrating diamonds. They have entangled millions of atoms inside clouds of cold gas. They've even attempted to entangle a microscopic living creature, a tardigrade, with a superconducting circuit. Even though this last experiment is debated, the trajectory is clear. Entanglement isn't a bizarre mathematical artifact confined to the microworld. It is a fundamental property of matter. The more we can isolate systems from external noise, the more massive the objects we can connect in this ghostly dance. And if we can entangle crystals and complex molecules, what theoretically stops us from scaling up even further? This connection isn't just a philosophical curiosity. It's becoming the foundation of an unprecedented technological revolution. We are building the quantum internet. Imagine a global communication network based on entanglement. When two particles are entangled, anyone trying to intercept them from the outside inevitably destroys the quantum state. It's a law of physics. If a hacker tries to eavesdrop on the communication, the bond breaks and the particles collapse into random noise. This makes quantum cryptography literally unbreakable, guaranteed not by mathematical complexity, but by the fundamental laws of the universe. Not only that, using this phenomenon, we are achieving quantum teleportation. We aren't moving physical matter, mind you. We are transferring the exact information, the complete quantum state of one particle, to another distant particle, destroying the original in the process. The receiving particle becomes indistinguishable from the original. We are learning to manipulate the invisible threads that connect reality. What was considered a fatal flaw in the theory a century ago is today the engine of the most powerful computers ever conceived by the human mind. But here we need to take a crucial pause. We must rigorously separate verifiable physics from fantasy. If entanglement is instantaneous, why can't we use it to send messages faster than light? Why can't we talk to astronauts on Mars with no delay? The answer is ruthless. The universe has a built-in safety mechanism. Remember the spinning coin? When you measure your particle on Earth, you get a random result, heads or tails. You can't force the particle to be heads to send a signal. And because your result is purely random, the instantaneous result on Mars will also be random. The astronaut will just see a meaningless sequence of heads and tails. To realize that your data is correlated, to extract the message, you have to compare your notes. And to compare notes, you have to send a normal signal, maybe via radio, that travels at the speed of light. Entanglement connects particles instantaneously, but nature categorically forbids us from using this connection to transmit useful information faster than light. The universe's speed limit remains intact. Quantum information is shared, but our access to it is strictly limited by the laws of relativity. This limit brings us back to the physical reality of our labs. But there's one last implication, a thought that pushes science to the very edge of philosophy. Think about the origin of everything. 14 billion years ago, the Big Bang. In that unimaginable moment, all matter, all energy, all the space that today makes up our boundless universe was compressed into an infinitely dense and hot point. Every single elementary particle was in intimate contact with all the others. They were born from the same primordial quantum cauldron. If interacting particles become entangled, then it's physically plausible that in the very first instant of creation, everything was entangled with everything else. Then cosmic inflation expanded the universe at unimaginable speeds, separating this primordial matter, creating galaxies, stars, planets, and finally us. From a physical standpoint, decoherence has destroyed almost all of these primordial bonds. But philosophically, it leaves us with a powerful image. Perhaps on a fundamental and invisible level, the fragments of that original unity retain an echo of their connection. Perhaps the separation we experience every day between ourselves and the universe is, ultimately, just a matter of perspective. We have journeyed through one of the most difficult and counterintuitive concepts the human mind has ever discovered. We've seen that the speed of light is an absolute limit for transmitting information, but that nature possesses a network of instantaneous connections operating beneath this limit. We've seen that the universe doesn't have a pre-written script, but decides its shape only the moment it interacts. And we've seen how this quantum weirdness is becoming the tangible technology of tomorrow. These aren't speculations. They are facts measured, calculated, and tested every single day. Entanglement teaches us a lesson in profound humility. It proves that our senses, evolved to hunt and survive on the savannah, perceive only a superficial fraction of reality. We see separate objects, unbridgeable distances, a fragmented universe. But when we turn on our mathematical instruments and descend into the quantum dark, we find a world where separation is blurred, where two things can be one, and where an action in one point of the universe resonates in another, in a silent, instantaneous cosmic heartbeat. The next time you look up at the starry night sky, think about this. That cold, empty space between the stars might not be empty at all. It might be woven with billions of invisible quantum threads, binding together the particles of distant worlds in a dance we will never see with our own eyes, but which we now know exists with absolute certainty. Reality is far stranger, far more complex, and far more deeply connected than we could ever imagine. This is Unseenium, where we make the invisible fabric of our universe visible. Subscribe to keep exploring the incredible architecture of reality.